Welcome to 5.5 Solve Trigonometric Equations. In this section we will start to use all the basic knowledge that you've reviewed and your algebra techniques, especially factoring. The first example shows you how useful GCF is for solving equations. If you look at our equation here, we have sines and tangents, two different variables. So the solution there is to set to 0, as I've done here, subtract sine from each side, and then do GCF. You are going to be tempted to divide out the sine of theta, but we'll talk about at the very end what you risk when you do that. Okay, so we're going to factor out the GCF, and in that case, there's a sine theta in each side. So we have sine theta times the quantity tan theta minus 1 equals 0, because we divide sine out of the sine tan and out of sine. Then we have our two pathways because of the zero product property, either sine theta equals 0, or we have tangent theta minus 1 equals 0. And of course we can isolate tan now because it's the only trig function there, and we get tan equals 1. Now most of your handout, most of your problems are going to be 0 to 2 pi. So what we're going to do is find the answers, all the answers in your unit circle. I'll just draw it over here just for the first one, just to refer to this again. We have our 4 quadrants, and because we have a quadrantal angle here, I often like to at least draw the crosshairs and see if we can remember where sine is 0. Remember, sine is your y value, so sine would be your y value at sine would be 0 at 0 and at pi. Okay, so on this side, our solution is theta equals 0 and pi. Those are the two values for which the y value is 0 on the unit circle. And here we have tan equals 1. If you memorized your basic facts, you remember that is a reference 45 angle, and it occurs in quadrants 1 and 3. So our theta is going to be our reference angle, or 45, except we're doing radians. So it'll be pi over 4. That'll be quadrant 1. I always write the quadrants just to keep myself organized. And then you have to remember which quadrant is it that is also positive. There's always two quadrants that are positive, two quadrants that are negative. And for tangent, it's quadrants 1 and 3. So we need a quadrant 3 angle. So we need the angle that is just over pi, so that's 5 pi over 4. And we're done with this problem. We have 4 answers. Notice you lost half the problem if you divided out sine theta, because we have 2 answers that you wouldn't get. You would just get the tan minus 1 equals 0, and you would only have half of your answers. So do not divide out, set to 0. Our second problem illustrates when we have to write all or infinite solutions. In other words, not just from 0 to 2 pi, but we go around the circle multiple times in either direction and find all the quadrant 1 and quadrant 3 values in this case, because we have, in this illustration, we have tan x equals 1. Well, we know the reference angle is at pi over 4, and then we also have a quadrant 3 angle at 5 pi over 4, and because tan x has a period of pi, those two angles are pi apart. In other words, you would go pi, or a semicircle, or 180 degrees to get to quadrant 3, and then back again 180 degrees to get to quadrant 1 again, and you could keep going around forever, and you could also go in the other direction, forwards or backwards, to find an infinite number of angles. You would start with pi over 4, then 5 pi over 4, add pi again, and get to 9 pi over 4, or be subtracting and go in the other direction. So the way we write that answer is we write the original angle position, in this case quadrant 1, and then we write what n times whatever it is we would have to do to add to get to the next answer. In this case, for tan x has a period of pi, so it would be n pi. Now let's look at the one we have here. It's not a tangent, it's a cosine. So the first thing you're going to do is to isolate. So when we subtract square root of 3 and then divide by 2, we get cosine of x equals negative square root of 3 over 2. Now we decide or remember that the reference angle for cosine being square root of 3 over 2 is 30 degrees. I find it easiest to remember them in degrees, but then remember you have to convert that to radians. It is really pi over 6. And we're going to be in quadrants 2 and 3. Now quadrants 2 and 3, you're not going to be adding pi to get to the next one. So for cosine and sine, which have a period of 2 pi, we have to consider the two quadrants where cosine x is negative square root of 3 over 2. So we'll have a quadrant 2 value. And remember that would be the just less than pi. That would be 5 pi x equals 5 pi over 6. And then we want consecutive quadrant 2, so we would have to add 2 n pi. In other words, we're going around 2 pi n times. And then we have quadrant 3, x equals, remember quadrant 3 is just over pi, that's 7 pi over 6, and plus 2n pi. Now you might say, why do we write 2n pi? Why not write n 2 pi? It's just, as long as you have the 2 in there, it doesn't matter where you put it really. But we just want to be sure that you know that to get to quadrant 2 from 5 pi over 6, you are going to go around 2 pi n times. The remainder of the problems we'll be solving on 0 to 2 pi. This is a quadratic example, and you'll notice that we're used to seeing ax squared plus bx plus c, but now, because we're in trigonometry, we don't have x's, we have sines. Now because we have sine squareds and sines, that's the clue that we need to set to 0 right in the beginning before we start out. And we're going to be factoring it. So what I've done so far that's already shown here is added 1 to both sides, so we have a 0. Now we have all this on the right, and we also have a negative 2 sine squared theta, which is very hard. It's very hard to factor a quadratic that has a negative leading coefficient. So in this case, we're going to solve that problem by writing everything on the left. Notice as you move terms to the left, they change sign. So now we have a positive 2 sine squared theta minus 3 sine theta plus 1 equals 0. Now at this point, notice I've written in green on the right. If you would like to, if you're having trouble seeing quadratics factoring with the sine theta in there because it's so many letters, you could rewrite it, just let u equal sine of theta and substitute the letter u for all the sine thetas. If you find it easier to factor that way, it's up to you. But you'll find, as you see I have factored here, you'll find that most of the factoring that we have where the leading coefficient is not 1, you'll find that there really aren't that many choices. They're fairly simple ones. In this case, for example, you have a positive 1 as a third term, so the only things that you can use to make a positive 1 and a negative in the middle are a negative 1 and negative 1. So now we're ready to finish out the problem. We had 2 sine theta minus 1 on one side equals 0, and then sine theta minus 1 equals 0 on the other side. So we have sine theta equals 1, which we're once again looking at the unit circle. Where does the y value equal 1? So we're ready to write our answer there, and our theta equals pi over 2. That's where the y value equals 1. And then over here on the left side we have sine theta equals 1/2. So once again we're taking reference 30. It's positive, so it's quadrants 1 and 2. So the quadrant 1 30-degree angle, of course, is pi over 6. Oops, we should write theta equals. Always write theta equals. And then the quadrant 2 angle, just under pi, is 5 pi over 6. So there you have your 3 answers. Pi over 6, 5 pi over 6, and pi over 2. These examples in number 4 illustrate using the square root property, and we're reminded to, whenever we're taking a square root of something squared, to remember the plus minus. And I'll show you what it is that is so nice about when you have plus minus answers. So once again, there's only a cosine squared in this first example, so I've already shown isolation here. So now we're at the point where we're going to take the square root of both sides. So we take the square root of cosine squared and the square root of 3 over 4. Now once you've seen this, you might forget your radical math, but remember, you won't always write out these steps. But when you take the square root of a fraction, you split it into the square root of the top, square root of the bottom, and remember square root of 4 is 2. So there is our old familiar square root of 3 over 2. However, it's the square root of cosine squared, so cosine of theta here will be plus or minus square root of 3 over 2. Now what's so nice about that is you automatically have all 4 quadrants. You don't even have to think about which are positive and which are negative, because you'll have 2 positives and 2 negatives. So in this case, remembering that the cosine of theta is square root of 3 over 2 when we have a reference angle of 30. Remember, the sine of 30 is a half. So if you have the cosine of 30, it will be the square root of 3 over 2. So you're automatically going to use all the pi over 6 angles, and it's 1 pi over 6. Remember, just under pi is 5 pi over 6. Just over pi is 7 pi over 6. And then 1, 5, 7, 11. Fourth quadrant is 11 pi over 6. And then you're done. So that's very simple. Now this next one's simple too, but it illustrates what you're going to do when you have reciprocals. Remember, cosecant squared is the reciprocal of sine. So before you worry about that, you take your square root of both sides, and so your cosecant of theta equals plus or minus square root of 2. And we can't deal with cosecant of theta, so we're going to take the reciprocal of both sides. So the reciprocal of cosecant of theta is the sine of theta. Remember, cosecant and sine are reciprocals. So if you're going to flip the one side, going to flip a cosecant, and get a sine, you're going to flip the other side, plus or minus 1 over square root of 2. Now you should recognize that. You don't have to, you could rationalize it if you want to, but it's extra work because we know that is square root of 2 over 2. So that means your angles are 45-degree angles, which means you are at pi over 4 is your reference angle, quadrant 1, And then the pi over 4 angles are 1, 3, 5, 7 in the 4 quadrants. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, there you go. That's the nice thing about plus minus. You just do all quadrants and you don't have to think much. Okay, this last one illustrates using a Pythagorean identity to get an equation to one variable. We have, and once again we're solving 0 to 2 pi, we have a cosine squared in here, but we also have a sine. Now there's no question about which one to substitute because we don't have any Pythagorean identities that are for sine. We only have squareds. So you go through and remember, write them out if you need to, that if we want to get rid of that cosine squared, we're going to have to put in 1 minus sine squared. So I've done that. I've done the first few steps here. There's your 1 minus sine squared. And don't forget to use parentheses. Don't forget to distribute. Very common error is to forget to distribute. So when you distribute, you get 2 minus 2 sine squared theta. And then, once again, we don't have, first of all, you do want to put it in order. Always put the sine squared first. But we have a negative 2 sine squared theta. Students often make mistakes when you try to factor a negative. So my strong advice to you is get rid of the negative. In this case, we're going to just multiply everything by -1 on both sides. And so we'll get our 2 positive 2 sine squared theta minus 3 sine theta minus 2. And then 0 times -1 is 0. Now once again, if you would rather write that as 2u squared minus 3u minus 2 to clear your brain a little bit and think of your factoring, that would be great. But if you just don't forget to put the signs back in when you're done. But if you'll notice, most of the factoring we have here is fairly simple. There's only a few things that multiply to be -2. And I'm just going to pretend I tried them all. And we'll just put in the answer is 2 sine theta plus 1 times sine theta minus 2. Now this problem illustrates something that happens sometimes and is very handy. When you have, you remember you're going to set each one of these equal to 0. So on the left side, I'm just going to skip ahead a couple of steps. You can show all the steps if you want, but I'm just going to skip ahead. In my brain, I'm subtracting 1, dividing by 2. Some of you that don't like to write would rather do mental math than skip a few steps here. Then we know sine of 30 is a half, so we're talking about pi over 6, but we have negative quadrants, so we're talking about quadrants 3 and 4. So theta will be quadrant 3 is just over pi, so it will be 7 pi over 6. And then 7, 11, you'll have your 11 pi over 6 in quadrant 4. But this is the great part about this one is, look at the right side, sine theta equals 2. Well, you should spot that right away. You don't need a calculator to spot right away. That is not possible because sine can't be greater than 1, so you don't even have to work on that side. You just cross it off and your answer is 7 pi over 6 and 11 pi over 6. Okay, now the most important thing in this section is you have to get in there and do it. Listening is great for the very first step. Watching is great for the very first step. Reading is good when you want to check your answers in between, but you've got to get in there and work on it yourself. It's never going to come to you unless your brain starts to work on it on its own. So have fun with this and put a lot of work into it. It'll pay off.